Hey guys, so today we're going to discuss about the question called as longest increasing path in a matrix. So this is actually a hard question, a Leetcode hard question, but to be honest, this is not that hard question when compared to some other Leetcode hard questions. Like it's a doable hard question. Like it's not like you cannot do this question in your first attempt like that. It's a bit easy hard question. So let's start reading the question. So given an m into n integers matrix, return the length of longest increasing path in this matrix. So what they're trying to say is they'll be giving you a matrix which contains m into n integers in it, and you have to find the longest increasing path in that matrix. So and in this matrix you can only move in four directions, which is up and down, left and right, but you cannot go diagonally, or you cannot go outside the boundary of this matrix. Outside the boundary in the sense like moving out of the number of rows or number of columns. So let's try to know what is this longest increasing path. Let's try to know that. So let's take the given example itself. So let's say we have a matrix of 3 by 3. So as the given example contains 3 rows and 3 columns, right? So it contains 3 by 3 matrix, and let's take the numbers 9, 9 and 4, 6, 6 and 8 and 2, 1, 1. So now, like, let's start from the beginning, from this cell. What do you think the longest increasing path from this cell would be? Let's see the adjacent cells. Let's try to do DFS from this cell. So if you see the right cell, this cell is not greater than the current cell. So we come back again. We go down. 6 is not greater than 9. So we come back. So at max from this cell, the maximum would be 1. So let's keep note of them as well. So we have some other matrix. So from this cell, which would be 0, 0, the maximum would be 1. So now let's so let's come from the second cell. So this is the second cell. So from this cell we perform DFS. We go towards right. This is not greater, we come back. We go down, not greater, we come back. We go left, not greater, come back. So from here the maximum would be 1. Similarly from 4 as well. We go left, it is greater. From 9 we see again if the adjacent ones are greater. It is not greater, we come back. We go down, not greater, we come back. We come back to 4 again. Again we go down. From 8 we see if there are any adjacent cells which are greater than 8. No, we come back to 4 again. So till now from 4 we have found the maximum path is 2. Maximum increasing path is 2. So we can keep track of that. So similarly, if we perform similar DFS for all the cells, though, so for 6 this would be 2. So for this 6 it should be 2. So for this 8 there are no adjacent cells which are in increasing order. So this would be 1. So from 2 this would be 3. From this one this would be 4. So from this one this would be like we go 8. This would be 2. So from all the cells the maximum is this 4, right? So that actually means if you start from 1, the maximum path the maximum or the longest increasing path would be 4, which would be from 1 to 2, 2 to 6 and 6 to 9. So this is the longest increasing path in this matrix. So this is the normal brute force approach, trying to do DFS from all the cells and finding the maximum increasing path from the particular cell and keeping track of the maximum or the longest one. So this is the brute force approach. So like if you clearly see here, don't you think we are doing the same thing again and again? For example, let's say after doing this, after performing DFS and finding the maximum path from 2, then only we are coming to 1, right? So and we are storing it. If we can store that longest increasing path from 2 at some place, and when we come from 1 to 2, and if we have a value in here which is stored already, can't we return this 3 to 1 instead of doing the same DFS again from 2 to 6 and 6 to 9? Yes, right, we can store them and take the stored value, right, instead of doing the same DFS again. we are actually trying to do memoization, trying to store the value instead of doing it same again and again, right? So this is basically like a DP solution, like a memoization solution. Instead of doing the same thing again, we store the value and take the value from there when you try to reach the cell. So let's try with the example how this memoization works. So now let's take the previous example only. Let's take the previous example and let's try to solve the solution using memoization. So let's start from the beginning, from the first cell. So we are at here. So let's take from 9. What is the longest increasing path we can find? Let's try to do DFS from 9. So from 9 we go to the adjacent one, which is 9. This is not greater, and we come back. We go downwards. This is not greater, which is 6. So we come back. So at max, the maximum increasing path is one itself. So we store it in another extra matrix called as DP. Let's name it DP, and we store it in this cell, which actually means at 0, 0, which is 9. So the longest increasing path from this 0, 0 would be 1. So similarly, we start from the next cell. So here we do DFS. So we see whether the adjacent one is increasing or not. It is not. We come back. We see the right side. This is not greater. We come back. We go down. This is not greater. We come back. So again, so maximum would be 1 from here. So we store it in this DP matrix. So now we come to 4. So now we perform DFS from here. So we go left. Is 9 greater than 4? Of course it is. So now we see whether we have already wasted this 9 or not by seeing the DP matrix. If at all, this matrix DP contains number other than 0, because initially the matrix contains zeros, right? In a normal array, normal 2D array contains zeros. So if at all, if we visit some adjacent node and that particular cell in the DP matrix is not 0, then that actually means we have already visited that cell, right? So instead of performing DFS from this cell again, we can take the value from the DP array and send to 4, right? Of course we can. So what we can do is, I'll be sending the value of this 1 from 9 to 4. So this is 1. So now we have removed half of the DFS, right? So now coming to 8 from 4, we go to 8. So 8 is of course increasing, but we haven't visited yet. So now from 8 you see if there are any adjacent cells. From 8 to 6, it is not greater. We come back. We go downwards. This is not greater. We come back. So we store the maximum from 8. So for now, from 8 it is just 1, right? So now we will be storing 1 at 8th cell. This is gonna be 1. So now we return 1 plus 1. So this is gonna be 1. So it is going to return 1. 9 is going to return 1. So now we find the maximum of these two. So for these two, as they're equal, so it's going to be 1. So maximum of the two plus the current one, which is going to be 1, because we also have to add 4 in the path, right? So here at 4th position, it's going to be 2, because maximum of these 2 plus 1. So it's going to be 2. So now coming to this position, which is 6. From 6, let's try to find the adjacent cells which are increasing order. So we go towards right. This is not increasing. We come back, and again we go towards the top. Now let's see, this is increasing. So now let's see if it is visited or not. Of course this is visited, which contains value 1, right? So now we return 1 to 6 from 9. And again we go downwards. This is not increasing. We come back. So now we find the maximum. Until now from 6 we have gone to only single cell. So we take that 1 and we add plus 1, because we also have to add 6 in the path. So from 6, the maximum longest increasing path would be 2. So now we'll start from this cell, which would be the middle cell. So we go towards the left. This is not increasing. We come back. We go top. This is increasing. But so now let's see again. if it is visited or not. It is visited because it already had 1. So now we send 1 from 9 and we come back. Now we go to 8. 8 is already visited. We have got to know the longest increasing path from 8 when we have done DFS from 4. So we take 1 from 8 and send to 6. So now we go down. 1 is not increasing, right? So we come back again. So now we take the maximum of adjacent cells, maximum or the maximum of the longest increasing path from the adjacent cells, and add 1 to the current one. So this is going to be 2. So let's change it in the DP array. Now we come to 8. So now we see 8 is already visited, right? So we don't have to again DFS from 8. So now coming to 2, which is going to be this cell. So from 2, let's find out if there are any adjacent cells which are increasing. So we go first to the top. 6 is increasing. Now let's see if it is visited or not. Of course it is visited because we have already keep track of the longest increasing path from 6. So it is going to be 2. So now we will be returning 2 from 6. So now we go towards the right, which is 1, which is not increasing. So we come back. So now from 6 it's going to be 2, right? So now we add 2 plus 1, it's going to be 3. So from these 2, the longest increasing path would be 3. So now we come to the next cell, which would be this cell. We see if there are any adjacent cells which are in increasing order. So we go to the top. We already visited this 6, right? So which is this cell. So the longest increasing path from the 6 is 2. So we turn 2 to this 1. So we go to the towards left. So we see if this 2 is increasing or not. It is increasing. And we also see the longest increasing path from that 2. Yes, it is 3. So now we return the 3 to this 1. So we go towards right. This is increasing. So we come back. So now the maximum of these 2 adjacent longest increasing path is 3, right? So if you go towards this path, the maximum would be 2. So if you go this path, the maximum would be 3. So now we choose always the maximum one to find the longest increasing path. So now 3 plus 1, this is going to be 4. So from this cell, the longest increasing path would be 4. So now coming back to this again. From this one, we see the adjacent one. This is not increasing, right? We come back. We see towards the top, which is 8. This is increasing, but we have already visited 8, and we have kept track of the longest increasing path from this 8, which is 1. So we turn this 1 to this 1, and we add plus 1 because we also have to add this 1 to the path. So from this position, the longest increasing path would be 2. So now we have done with all the cells. Now, so if you want to find the longest increasing path in this entire matrix, so that would be the maximum of this, the maximum value in this DP array. So the maximum value in this DP array is 4. So now the answer for this matrix, which is the longest increasing path in this matrix, would be 4. So this is how the actual memoization of this question would be. So let's try to implement this question. So now we are having a method called as longest increasing path, which contains parameters of a matrix. So this is going to be our input, which is a matrix which contains m into n integers. So initially, let's create a DP array as required, as we have to store the longest increasing path from a particular cell, because we are trying to do memoization, right? So let's try to create a DP array. So I'm going to use it as a global variable so that I can use in some other methods as well. And I'm going to create 2 variables called as m into n. So m is going to store the matrix length. So this is going to store the number of rows actually. So matrix dot length, and n is going to store the columns. So now I'm going to define this DP of size m comma n. So now, as we have started in the example, starting from the beginning, we start doing DFS, right? From 9, from 4. So similarly, we'll try to take to a nested for loop. This is going to be like a normal nested for loop, and try to do DFS from each cell. So for int I 0, I is less than n m I plus plus, and for int j is equal to 0, j is less than n j plus plus. Now we'll see if dp of I comma j is 0 or not. If why are we saying if it is 0 or not? If it is 0, that actually means we haven't visited that cell, right? Only if we haven't visited that cell, then only we are going to perform DFS to that. So if it is not, if it is 0, then perform DFS from the I comma j cell, and we're also going to pass the matrix. We may use matrix in that method. So now let's try to implement that DFS. So I'll be using a method called DFS, which contains parameters x and y and the matrix. So this x and y are going to represent the coordinates of the cells, like the row, the which row and which column. So now, first things first, what we are trying to do is we'll keep a variable called as max. So this is going to keep track of the maximum path from this particular cell. So now I'll be as the question said, we have to go to 4 directions, right? Which is top, down, left and right. So for that I'll be using a special array. So let's name it as dx. So this is going to be 0 0 1 minus 1. I'll tell you what this is. So this is going to be 1 minus 1 0 0. So this actually represents the 4 directions. So the dx of 0 and dy of 0 is going to be 0 comma 1, which increments the column. Similarly, 1 comma the dx of 0, dx of 1 and dy of 1 going to decrement the column. So this is how it works. In order to go to 4 directions, I'm going to use this array. So for int I is equal to 0 and I is less than 4 I plus plus, the reason why you are using 4 is this is of length 4, right? That's why. So I'm going to find the adjacent cells. So dx of I plus current x, and similarly dy of I plus current y. First things first, I have to make sure this cell is valid or not. It might be a cell which is exceeding the boundaries as well, right? So I have to make sure this is valid. So I'll be using a separate method for that, and that method would be returning a boolean whether it is valid or not. So this contains parameters I comma j, and a cell would be valid only if the row is greater than or equal to 0 and column is greater than or equal to 0, and the row should be less than m, j should be less than n, right? If this condition matches all of these, then it is valid. So now let's come back here. So if it is valid, or if it is inside the matrix, the cell is inside this matrix, and that cell value should be greater than the current cell value, right? If matrix of u comma v is greater than matrix of x comma y, then we can go to that cell. So what we're trying to do, we go to that cell by passing u and v and matrix. And now when we go to that cell, we have to find if it is already visited or not, right? So for that, when you call this DFS, we're again going to come to this position, right? So if we can even do this. So if dp of x comma y is not equal to 0, or if it is already visited, then return the dp of x comma y, right? So if it is returned, we keep track of the maximum in this position. So max would be math dot max of max and the returned value in this method. So at the end, as I said, we also have to add +1 so that the current cell would be added in the path. So we have to store that in the dp array first. So dp of x comma y would be max plus 1, and we also have to keep track this length value in the answer as well. So answer would be math.max of answer and max plus 1, and I'll be returning this max plus 1 to the previous cell which has been calling this cell. So as I have created an answer variable, I'll be creating the answer variable here. So at the end I'll be returning the answer. So this is pretty much the solution. So let's try to compile this, hoping for no compilation errors. Oh yeah, it got accepted for the normal test cases. Let's see for some more test cases. Oh, it passed. So let's try to submit this code. Yeah, it got succeeded. So this is how you find the longest increasing path in a matrix. So as I said before, this is not that hard question, like when compared to some other hard questions. This is an easier hard question. Like we can easily find out you're trying to do something repeated again and again. Like you're trying to instead of doing the same thing again, you are storing it in some other DP array. So there are many similar questions related to this, so you can try to solve them as well. So if you like the video, please make sure you like, subscribe. Thank you.